Okay, it's a good in the sense that tomorrow is Saturday. Now today I would like to go through the whole 45 minutes I like to spend on shear force and bending moment distribution equation. Okay, we are going to look at this. So I believe you guys have done this before in 2P. Okay, so I'm going to quickly do a very swift revision on this. Okay, now we know that shear force can be either positive or negative. Am I right? So when you sketch your shear force diagram, so when we look at our shear force diagram, we have our x-axis and y-axis. So our shear force, and this is x, we have positive shear and we have negative shear. Can anyone tell me what does it mean by positive shear and negative shear, please? Can you remember? No? No answer? Anyone? Yes. Almost there. You're about right. Okay. So what do we mean by positive shear and negative shear? Okay. In positive shear, the element will have the shear stress acting in this direction. So this is positive what? Shear. Okay, magnitude. If it's negative shear, this is the direction. So later on, maybe in week 6 or 7 or week 8, when we go into Mohs circle, I will elaborate more on this. Okay, but for now, I want you to look on the element. Positive shear means the element is deforming in that direction. Negative shear is forming in that direction. Are we clear? Okay. Now, both negative and positive shear are as good or as bad. There's no such thing that positive shear is better than negative. Are we clear? Okay, there's no such things like that. Okay. Now, the next thing we will look at is bending moment diagram. Okay, it's our bending moment diagram. So in our bending moment diagram, again, this is our x, this is our bending moment. Okay. Now, what does positive bending moment mean? Anyone, please? Yes. Yes. So positive bending, okay, in terms of now, I'm going to look in terms of deformation pattern. In this course, I'm going to elaborate a lot on deformation pattern. Because the mechanics course, we have to what? See to what? Believe. I'm not going to allow you to just apply the damn formula blindly and like positive or negative here. Negative here. So what? No, you have to what? Visualize. We just visualize what? What is what? Positive here and what is what? Negative here. Okay? Now, in terms of positive bending moment, okay, if we were to look at the deformation pattern, okay, positive bending moment, the deformation pattern is a what? Smiling face. Okay. And deformation pattern, sad face for what? So this is for positive bending moment. And this is for what? Negative what? Bending moment. Deformation pattern means the deflection. Okay, I'll put down here again the deflection. Okay. Let's do something fun for once. Okay. How many of you are demoralized with this course already? Put up your hand. I don't mean to demoralize you. If I did, I do apologize. Okay? Okay? I sincerely do. Okay? But what do you mean but, Eugene? You don't say but after making a statement like that. Now, if we were to look at this structure, you have to look at this structure. Can you sketch for me? I'll give you 2 minutes. Can you sketch for me the deformation? It's okay to make mistakes. Can you sketch? Okay, I'll walk around and okay, I will not disturb you. Can you just sketch how the deformation pattern look like? Don't be afraid to make mistakes. Okay, just sketch. Right? So at point, we know at point A, point B, there's no motion at all. Right? Or no deflection at all. But between A and B, you have a deformation. Between B and C, you have a deformation. So just sketch. Okay? I give you a good 1 minute. Very good. Okay? Just sketch. Don't be scared to make mistakes. Do on your own. If you make mistake, it's fine. Okay? We make mistake here, we share within this mistake to all. You go to industry, you make mistake, what will happen? Eugene will come after you. Are we clear? Okay? Let's sketch it out. Are we good? So I'm going to sketch now. Okay. So for here, I'll have something like this. I'll use a different color. We'll have something like this. Then at some point, it's going to curl up. And then it's going to come down. Okay. So this, or it's going to come down like this. This is known as our what? Deformation pattern. Or this is our deflection pattern, whatever you want to call it. Okay? Now, with this, you can more or less have a sketch of your bending moment diagram. Yes or no? Okay, more or less, we are going to now sketch the bending moment what? Diagram. Okay, so the bending moment diagram, the rule says what? If this is X, this is bending moment, okay? And if we were to look at deformation, at the top, the deformation is smiling face. At the bottom, the deformation is what? Sad face. Yes or no? So I'm going to sketch. Okay, I'm going to sketch. So I'm going to sketch from here. This is just a sketch, by the way. Okay. So this is my bending moment diagram. Okay, and this is X. This is my point A. This is my point B. And this is my point C. Okay. And we know for the fact at point A, the bending moment is equal to 0. And we know for the fact at point C is also equal to what? 0. Okay. So this is, again, I repeat, this is just a sketch. Okay. So I will draw a line down here. Because at that point, right, the deformation, so over here, the deformation is a smiling face. And then over here, the deformation is a what? Sad face. Yes or no? Right? So if we're going to roughly sketch, okay, so we know that over here, right, somewhere over here, there'll be a transition. Okay, so this is just a sketch. So I'm going to sketch smiling face, smiling face, smiling face. Then it has to come into the what? It has to pass through 0. Then it will go to a set face, set face. Oh, not straight line. Okay, we'll go to a set face. Okay, and this is my sketch based on what? Deformation. Can you see? So from this region to this region is what? Smiling face deformation. Yes or no? From where I draw the chain line onwards, the deformation is what? Set face. Okay, that's a set face. This is a sketch for our check later on when we derive our shear force and bending moment equation. Are we correct? Okay, so by looking at the deformation pattern, we can more or less sketch the what? How the bending moment diagram will look like. Are we clear? Okay, so if as an engineer, calculating the value is one thing, you have to have the feel whether does your calculation make sense or not. Okay, so this is the first check. Okay. So what I'm going to do is going to be a quick revision. So this is something you have not seen before, something new. Am I right? You all have not sketched bending moment diagram based on deflection. Am I right? Yes or no? You all learn this in 2P? Yes? Okay, if you learn that, yes, I did not know that, okay? And then we know what is our shear force diagram look like. Now, some of you have said, Eugene, then how is this based on the deflection, okay? Based on the deflection, okay? Based on the deflection now, how do we relate this to our what? Our element, okay? I will highlight that later, but first we are going to look at shear force and bending moment equation, okay? So now, we are going to apply, there are two techniques to derive this, okay? So I'm going to show you the technique that you are most familiar with, okay? So we are going to apply the integration method. Okay, now point A to point B to determine, okay, I need to write down to determine shear force and bending moment distribution equation. Okay, I will highlight over here. The emphasis is on what? Integration method. Okay. So we know using integration method, we know that dv over dx is equal to minus omega as a function of x. Okay, so what we want to find out is we're going to determine between point B to point what? To point C, i.e., we have to highlight the limits that these sets of equation will only work for L, X, 3L over 2. Okay, so always remember the geometric datum is always on the left-hand side of the what? Of our structure. And over here, this is our what? X value. So in order to apply equation number 1, you guys all seen equation number 1 before? Yes, nothing new, right? So in order to look at equation number 1, we have to determine omega as a function of x between point B to point C. So this will be equal to what? So this will be equal to omega naught over L over 2 x plus by C1. Okay. So we know we come up with the equation. We know that omega as a function of x, this is equal to 2. Sorry, it has to be minus because the slope is coming down. Minus 2 omega naught x over L plus by C1. Why that is so? Because if we were to look at the beam, this is our point A, this is our point B, this is our point C. We are now focusing on the equation at this section. Okay, so this is the section that we are focusing our equation on. So this is our omega as a function of x is equal to minus 2 omega naught x over L plus by C1. Okay. So we